In this recording, we're going to take a look at getting started with Jamovi, and this is with a view to creating a table of participant characteristics or baseline characteristics, as we might see in this paper here. And the data for this paper is on Dryad, so that is what we're going to use. We're going to open this up and take a look at Jamovi, but the goal will be to get the information we need to create our own table, perhaps in Excel or Word. I think it's very unlikely that you'll be able to get Jamovi to produce a fully formatted table with a mix of variables like this, but we certainly can use it to get the information we need. So if we open up Jamovi, and to start with, we'll just open the data. So you need to go to the little hamburger button, and I've already got it sitting here. I'll just open up the CSV so it doesn't have any working in it. So that's a comma separated values file. If you save a Jamovi file, that's OMV, that will keep all of your output that you've worked on. So that's very handy. So you probably want to have two versions of every file that you use, the CSV or an Excel, or even a .sav, which is an SPSS file, and Jamovi can read that fine as well. And you can go through the open and find a file in your folder somewhere. So what we have is the data window and the output window. Anything that we do with the data is going to appear here, and it is dynamically linked to the data. So if we change the analysis that we want, or the table or the formatting or whatever, it will update for that section. We'll see that as we go. So for the Jamovi window here, you should be able to see these 4 tabs. Variables shows us exactly what we can see in the data, except it's showing us these variable names as a list, and we can add in an extra description if we want to. So this is very useful if you have a bunch of abbreviations and you don't necessarily remember what they are. And you'll need to open the relevant README file to find out what these are. We're not going to look at these today. We're just going to go through some of the ones we do know. So I could write in body mass index here. Although BMI is something that gets abbreviated so much, you might not need to really. When you produce any tables or graphs or analysis, it will just use this short name. It won't use the description. And this is different to SPSS, which we'll put in the description. So just if you're used to SPSS, just be aware that it doesn't work quite the same way. So this is our variables tab. If we go into the data tab, we can see the variables we have, and we might just want to check that they're all the correct type. So you can see that we have a little symbol for each variable. The little ruler means that Jamovi believes it to be a scale or continuous variable. The 3 dots is nominal, and I don't think we have an ordinal example here. No, they're all, but we can have a look at it. If Jamovi has guessed the wrong type, so this is an ID number, it looks continuous because it's a range of values, but actually these have no meaning because they're ID numbers. So if we double click, it will open up the information and we can change this to be an ID variable, which just gives it a little tag instead. If we go through, sex can stay as nominal, and we need to write in the codes. So you need to have the README file open. I don't remember what it is. So let me just guess that 1 is male and 0 is female. I might have this wrong. I can change it later. So when you type over the code, you can still see the code in the corner here, which is extremely useful in case you do what I do and put the codes in and then check that you're right later. So if I discover actually that I've got them the wrong way round, I can retype them, but I know what my original numbers are. So once I've done that, you can see that it's actually showing the labels here in the data column instead of those codes. So whether you like that or not is up to you. I'm not aware that you can force it to do something different. I mostly like that unless these labels are quite long, but then I guess I could change them. If we had specific missing values, we could put them into here. So you might have a missing value code like 999. I don't think there are any in this data set, so I'm going to leave this for the moment. We can change what the data type is, and these levels we can rearrange. So if you want them in a different order in the output, so if I want male to come first, I can bump that up, and this will change the order it presents in the output. I'm just going to leave it as the 0, 1 because that makes more sense to me at the moment, but I guess I can change that later. Now, age, you'll notice that this is not actually the age. So if we go back to the paper, the age is in years and the mean age was 56.83 years. So this is not the age, this is an age category. And most likely this has been done to protect the identity of the research participants. So we don't know their exact age, even though it has been used in the original research. So we need to go through and put in our age categories here. So I think it's 40 to 49, 50 to 59, 60 to 69, 70 to 79. And you can check that in the README file. So the README file is here. And you should always download a README file if it comes with the data. Otherwise, you won't know what the codes mean. And also, we have ordered categories. So this should not be nominal anymore. This should be ordinal. So I'm going to change that to ordinal. And you can see that the little symbol here has changed. We don't need all of these variables for this exercise, but you could go through some of them and check you know how to manipulate it. So I got to that by double clicking on the header, but you can also go to setup. If you want to create new variables of old variables, we do have the compute and a transform. I don't think we're going to need those today. We won't need to wait anything. So this is the data tab. The next tab we have is analysis or analyses. Now, if you've just downloaded Jamovi, you'll probably only see these first 5 options showing up. These are all extra modules that I've added in. And you can add in extra modules too by going to modules. And it will show you a list of modules that you can add in. The scatter plot is probably worth installing if you haven't done that yet. And the RJ editor allows you to run R code inside of Jamovi. So these are probably the only 2 that you would want to do now. And the rest, if we get up to it, we can install them. So if you're looking for a module, if you see something in my menu that you don't have, then go to here and have a look for it. So we can see that we have a lot of familiar tests and procedures here, but what we're after at the moment is just exploration, because we just would like to know some descriptive statistics. And once we've done this, then we can see what this final tab is for. So this little word here, scatter, that SCATR is indicating that this has come from a module. So if you notice scatter here, that I've installed this and that's why that's showing up. So you may just see descriptives. I can't remember where Pareto chart comes from, but we don't need that. So to do the scatter plots, make sure you install the scatter module. Which actually we probably don't even need today anyway, but you could get it ready and have a play. So let's go to descriptives. And to get started, let's just look at sex. And we're interested in, if we go back to our original table, we're interested in the people who have non-alcoholic fatty liver disease and the ones who don't have it and the ones who do. Now, they've also done a test, which we're not going to do just at the moment, but this is the descriptive information. So for a categorical variable, we would be after the count and the percentage. So this is what we're going to try and have a look at. And often we want to just have a look at some graphs to understand the data better, even if we're not going to include them in the report at this time. So we have sex, and now we're after non-alcoholic fatty liver disease, which I believe is down here. And because I haven't put any of the codes in, it's just showing up with the 0 and the 1. So I actually could work out what the codes are based on, so we should have 390 males. It's not giving us, you can see that it's giving us the mean median. So the default is to treat it as a continuous variable. And we want the frequency. So we're going to tick that box and it's going to give us the count. So 390 males without. I could have just seen it actually from the overall 0, 619. They do not have it. So if I go to non-alcoholic fatty liver disease, and I'm going to type in no and yes, and you could type these labels differently if you want to match in with the paper. Oh, it didn't save my yes. And you can see that this is linked to everything else that we do. So it has updated this table straight away, which is very convenient. If you're working in SPSS and you have generated a table, or if you've been working in R or Python, once you've generated the output, that output stays, it doesn't update. So mostly I feel like this is a good thing, but it can accidentally be a bad thing if you forget that you're going to lose your previous analysis once it updates. If you do one thing and then just quickly do another thing, but you go over the top. So just be aware of it so you don't lose any of your analysis that you want to keep. When you click on the output, it will take you back to the window that generated it. So this is also very helpful. So if I do, let's just do a scatter plot for the sake of generating some more output, and maybe we can have a quick look to see if our cholesterol has a correlation. I don't know what this is going to look like. No, it's a bit of a mess. So if we have done some more output and then we decide we want to actually fix this up, it will take us back to this window once we click on it. And here it will give us this again. If you want to remove the output, actually click on the outermost window and remove, and then it'll get rid of it. So we have a few options here in this window. If we go into the three little dots in the top right-hand corner, we have some options for the number format, how many decimal places we want. 3 is most likely enough. Obviously, this will change depending on what you're doing, but in most cases, you might even only want 1 or 2, depending on which variables you're looking at. The references is what it was giving us below for where it's getting this from. And you can see that Jamovi is built using R. So a lot of the references will be to R, and you can click through and see that if you like. For some of the more advanced procedures, they may reference specific textbooks, or I'm trying to think who else gets referenced. I guess you'll see as you go through it, but you may see other references as you go through. If you don't want to see those, you can turn them off. I usually just leave them on. The other option we have here is for the syntax mode. So if you are using Jamovi as a quick option, but you do want to sort of learn about scripting at the same time, you can tick this option here. This code is R code, and if you put it into an R editor, it will give you this output. The only thing to note here is that all these libraries have been specifically written for Jamovi. So this is actually referencing the Jamovi library and the descriptives. So these commands are probably a little bit different to what you would use if you were using R by itself. You'd probably use a different library to generate a descriptive table. However, if you like any of the Jamovi output and you want to do it in RStudio, you can download the Jamovi library into RStudio and generate this output in R. I'm trying to think why you would want to do that rather than just doing it in Jamovi. There's probably a use case. So it is just an R library like any other library. And if you want to try out or if you just want to be aware of the syntax, you can see this. And this will hopefully build a little bit of intuition about how to read it. We can see that we want sex split by NAFLD. If we do any plots, there's only minimal editing we can do on them. So if we go back to here and we go down to the plots, we've got counts. So we really just want a bar plot. We don't have a lot of options here. This theme we can change. So there's not a huge number of options, but you can change them a little bit if you want to. And this is probably the main limitation of Jamovi, is the lack of editing available for the graphs. Now, if you did want a bar chart, but you wanted it by percentages, or you wanted it stacked or organized slightly differently, you can't do that through the descriptives, but you can do that through the frequencies tab. So if we go into frequencies and contingency tables, I'll just put in the variables quickly. You can see that we've got a lot more options for the bar chart, where we can change it from clustered to stacked. We can change it from counts to percentages. Whenever we choose a percentage, we have to work out what the percentages are out of, because it can be percentage out of sex, out of NAFLD, or out of the total. Usually it would be most intuitive to have the percentage out of the x-axis variable. So in that case here, and I'd probably want it stacked. That's easier. So this is slightly more complicated than you would do it in SPSS, because it's doesn't tell you the x-axis. You choose the x-axis and then you say within rows or columns. So it's almost an extra little step. If you want to edit this graph, like you want to change the font size, you would have to put it into another program, as far as I'm aware. You can zoom. It doesn't actually look like it's regenerated this graph. This actually looks like it has just zoomed in and it's a little bit blurry. So I'm not sure if that will do it for you. You can export it as an SVG or some other format and edit it if you need it. For this particular task, we probably don't need it at this stage. So that's getting a more advanced bar chart. The rest of the charts we can probably do if we're having a look at the data through the descriptives. Let's just go back and have a look at what we can generate here. So we've still got, even though we ticked the frequency table and we have the counts here that we need and the percentages, it's still given us this, and we might not want to see it because it's irrelevant for the categorical variable. So you can untick each of these, and if you had a continuous variable, maybe I'll just leave in the N and the missing. This might be useful information. And we can reformat this slightly as well. Okay, so we have the information that we want here. This is not quite in the format that we would want it here, but as far as I know, you can't really mess around with it much more. So if I was doing this, I would copy it and paste it into Excel, and then I would take the bits that I need. So I mean, what's fast and slow for doing this really depends on you. If you want to automatically create the format that has the number and then the percentage in brackets, you can use the concatenate function. So concat, and you would have to put in the count. Then you'd want to give it a space and then an open bracket, comma, the percentage, close bracket. That should work. This is where you have to fiddle around with Excel to get it in the format that you need it, because it's automatically divided by 100 because this was a percentage, and you wouldn't want the percentage sign here anyway. Percentage signs clutter up a table, and we usually try to keep the table as clean as possible. So what we want this to read is 14.4%. So you would have to fiddle around with Excel. And that's why, depending on the scale of what you're doing, if you're doing a small exercise, it's probably easier just to write this manually. I don't know if I'm putting in this in the right box. If you're doing a large table or you're working on a real project, then it might be worth coming up with a workflow and some formulas for creating the formatting. But that's your own choice at this stage. But I'm just pointing out that you, as far as I know, you can't do any advanced formatting in Jamovi itself. However, you can write sort of a pseudo report. If we go to the Edit tab, you'll see that it gives us options for adding text. So I could add in some notes here. These are the frequencies which match the paper. So I don't think I would use this for a real report, but you could add in notes for yourself about the analysis, and you can change the formatting here. So this is kind of a notebook style. I honestly very rarely use this because if I'm going to keep anything, I'd probably put it into a Word document, which is easier to share anyway. But just to say that it is there, and both in R and Python, you can create these kinds of documents, which are combinations of formatted text and output. Okay, let's go back to analysis and have a look at some continuous variables. I'm just going to open up a fresh descriptives window. I might turn off the syntax for now. Oh, lost my window. Let's go back to it. So let's have a look at a continuous variable. Let's do BMI, and we want to split by the, it's not scrolling, NAFLD. And we can change how this is formatted. Trying to think what will be, I don't know, that's your preference. It's not going to come out exactly how you want it. Probably this is easier to look at, but it won't be exactly how you want it if you're making a table to go in a paper. However, we can look at the information that we want. So typically when we're looking at a continuous variable, we're looking to see, should we describe it with the mean and standard deviation, or should we describe it with the median and the quartiles? And to decide this, it is best to look at histogram and perhaps a box plot. So I'm going to tick off histogram. We can do the density on top of it. I'm not sure if I find this useful, to be honest. SPSS will overlay a normal distribution, which is quite helpful. So given this data and this particular mean and standard deviation, what would a full normal distribution look like? I find that helpful. I don't know if I find the density helpful. And we could also look at the box plots. So we do expect that BMI will be a little bit skewed. As a population, we are getting larger, and we would expect to see a bit of skew to the right and probably some outliers. That said, there is a lot of data here. So if we were going to do a t-test on this, even though the data is not perfectly normal, the central limit theorem is going to apply because we have such a large distribution. You can do a normality test, and it's not normal. I don't really think that's necessary. I think you can usually make a judgment based on what it looks like and your sample size. You could look at a QQ plot if you want, and you can see that this is, if it was normal, it would follow approximately the straight line, but we've got this little kink at the end and also a tiny little kink at the beginning just because of the outliers here. And we can, these labels here are the row numbers. So if you were doing this as part of your data cleaning process and you wanted to just double check, is there a mistake for this, or is this a real observation? You can get the row number and go back and check that row in your data, and maybe check your original data collection sheets. In this case, we probably don't need the labels. And you could have a play with some of the other plots if you want to. The data plot might be helpful depending on how much data you have. I'm not sure that that gives us anything. Jittering just means that it spreads the points around, because if you have data points completely on top of each other, you can't see them. So if we just stack them on top, oh, it has stacked them lengthwise. Different software does this differently. Some software will just literally overlay it if you don't jitter it, but it doesn't look like that's going to happen. And potentially the mean is useful. I'm going to turn off the data. I don't like that. Okay. So the end result of this was, yes, it is skewed, but it's only a little bit skewed and we have a very large sample size. So I'm going to use the mean and the standard deviation. And then if I want to test, is there a difference in BMI at baseline between the NAFLD and not, I will just use a t-test. Okay, so hopefully that's enough of an introduction that you can start playing around with Jamovi. You can look through all the options. If you did want the median and the quartiles, you could put that in here. You could take out some of these other options. If you get the bits that you want, cut and paste them into Excel and reformat them. I would usually reformat in Excel first just to keep it a little bit clean before putting it into Word, because Word can be quite tricky with how it deals with tables. And just note that you can put more variables in here. So if you have several continuous variables, now just be careful when you do this, that if you have a lot of plots generating, it will do all of them. So it takes a second to think about it. So this is where you can see we've got way too much information. So I'm just going to take some of that out. There's no missing data, so I'm not going to look at that. So you can make this a lot cleaner. I wonder, no, that does not help. What I want it to split into the columns is the no and the yes, but I don't think there's an option to do that. So if we scroll down, you can quickly look at a whole. So this might be one where you would use the median and the quartiles, because it's really quite strongly skewed. I don't know what ALT is, actually. I'd have to look that up, but it does look like it stops at 0. So it's probably some measurement on the blood and it's quite skewed. So perhaps median and quartiles for this one. Again, I don't know what AST is, but we might want to check that what these outliers mean. That one looks fine, mean and standard deviation. Another really skewed one. So it looks like there's a few blood measurements that are quite skewed. So if you have a lot of variables, just take care when you pop them into this window, because depending on how many options you have selected, it will pause while it thinks about each of these to generate them. And if you've got a very large data set, it can take a little while for it to do that. And then you get your descriptives here.